This is the FCCC VR team, and we are tasked with the design of the virtual reality training tool. This is Kendall Britton, the project lead, and my teammates are listed below. The objective of our project is to create a virtual reality training tool to aid with new hire training and the retention of infrequent assemblies. We are also to create a virtual reality simulation template to generate additional creations for future assemblies. The specifications include that the VR simulation template shall be used to create and load assemblies in the virtual reality training tool. The design must be portable and easily assembled, and the required hardware includes the HTC Vive Pro. The VR simulation template will be an in-app assembly creation, have 3D runtime model importing, object interaction, a step-by-step process for scripting, and it will store data and the assembly will be added to a selection list within the tool. In terms of the VR training tool, our first application of the template is the body angle assembly simulation, where a user assembles the body angles into a chassis. They will place angles into the chassis, use a fixture to line up the angles, insert bolts into holes, place nuts onto the bolts, and then tighten the nuts with a torque gun, while there are scripts in the air to instruct the user while assembling. This is one application of the many VR assemblies that will be made. The deliverables include the VR training tool, one finished body angle simulation, an introduction video, the VR simulation template with base environment and preloaded tools, instruction manuals on how to use the template and the training tool, and the data comparison between the current training system and the new training system. Here we have some visuals of the current progress made on the body angle simulation. We have the base environment, which includes the chassis and the body angles, the tools used to mount the body angles onto the chassis, and the 3D models for the chassis and the various tools used. Here are some visuals of the snap zones, player model, user interface, and template. Snap zones allow for objects to be automatically placed in a designated area, where the player model is a virtual representation of the user's body functionality. The UI allows for scene traversal within the training tool, and the template includes a runtime importer that allows for importing of 3D models into the live simulation. For the training analysis, the current body angle training takes approximately 7.5 hours to complete. Our goal is to reduce this by at least 30%. With a 30% reduction, FCCC saves an estimated amount of $3,000 for every class of 25 new hires that are trained. Pre and post virtual reality training tool data will be collected through surveys to compare the current training process to the new VR training process. The expected results include a completed VR simulation template that is able to create new assemblies, a functional FCCC body angle assembly and the virtual reality training tool, and the 30% reduction in training. Our future design plans include the completion of both the VR simulation template and the body angle assembly, pilot testing of the VR body angle assembly to gather data to compare the current training process to the new VR training process, a creation of a new assembly using the template, and the creation of the instruction manuals.